I want you to try a little experiment with me. Close
Yeah.
your eyes for a second.
Okay.
Now, picture a dinosaur. Just let the very first image that pops into your brain float to the surface.
Right.
I am willing to bet good money that you aren't seeing a T-Rex snapping its jaws,
No.
and you aren't seeing a Triceratops. You are seeing a silhouette, a long horizontal neck, a heavy rounded body, and a tail that just stretches out forever.
It's the default setting for the word dinosaur. It's the logo on the gas station sign. It's the cartoon on the cereal box.
Exactly. It's the plastic toy in the sandbox. You are picturing the Diplodocus. It is the sheer ubiquity of this animal that makes us think we know it. It's the celebrity of the Jurassic. But here's the thing about celebrities.
The public image isn't the whole story.
It's usually a lot simpler and honestly a lot more boring than the reality.
That is the perfect way to frame this,
Yeah.
because the actual animal, the living, breathing, biological machine that was walking around 150 million years ago, is infinitely stranger than the museum mount we're all used to.
We are talking about a creature that has been completely reinvented by science, specifically by studies that have come out as recently as 2024 and 2025.
Yeah.
We're talking sonic booms, iguana spines, sensory tails, and a scientific rivalry that was basically a soap opera with shovels.
And we can't forget the diplomacy. This isn't just a biological success story, it's a cultural one. The reason you have that specific silhouette in your head is because of a very specific collision of Gilded Age wealth, international politics, and industrial manufacturing.
So that is our mission for this deep dive. We're going to take that dusty gray plastic toy in your head and replace it with a high-definition Technicolor reality. We have a massive stack of notes here from the 1870s right up to last year. Let's unpack the Diplodocus.
Let's do it.
And I think we have to start with the name itself. It sounds heavy. Diplodocus.
It does sound heavy. It's a Neo-Latin term derived from Greek. Diplos means double, and dokos means beam.
So literally the double
The
beam.
double beam.
It sounds like a gymnastics move, or maybe a specific type of steel girder.
Well, the steel girder comparison is actually pretty apt. When Othniel Charles Marsh named this animal in 1878, he was looking at the chevron bones.
Oh,
These are the small bones on the underside of the tail vertebrae that protect the blood vessels and nerves.
Usually those look like a V, right? Hence the word chevron.
Exactly. But in this new dinosaur, Marsh noticed something weird. The chevrons had these double protrusions, beams, sticking out both anteriorly and posteriorly.
So forward and backward.
Forward and backward. It looked like a double beam.
And at the time, he thought this was the trademark feature. Like if you find the double beam, you found a Diplodocus.
Right. He thought it was unique. As it turns out, paleontologists have since found similar structures in other sauropods, like Mamenchisaurus.
Oh, yeah.
So it wasn't as unique as he thought, but the name stuck. And functionally, it makes a lot of sense. When you have a tail that is 40 or 50 feet long and incredibly heavy, you need structural support. Those beams likely acted as skids or guards to protect the delicate plumbing of the tail when the animal rested it on the ground.
So the name is all about the tail. But the reason this dinosaur is famous isn't because of its tail bones. It's because of a man named Andrew Carnegie.
Oh, yeah.
And I love this part of the story because it feels so modern.
Yeah.
It's basically branding.
It is absolute branding. This
Yeah.
is the Diplodocus diplomacy era. Andrew Carnegie, the steel tycoon, was one of the richest men in history. He was building his institute in Pittsburgh, and he wanted a centerpiece.
He didn't just want a bone.
No, he wanted a giant dinosaur.
Go find me a monster, basically.
Essentially, yes. In 1899, his team excavated a near-complete skeleton in Sheep Creek, Wyoming. And naturally, because he was writing the checks, they named the species Diplodocus carnegii.
Which is a smart move if you want to keep your funding.
Very smart. But Carnegie was a visionary in terms of influence. He
Yeah.
realized that this skeleton was a sensation. So he didn't just put it in a hall in Pittsburgh. He commissioned a team to create plaster casts of the entire skeleton.
And you have to pause and appreciate the scale of that. This is an animal nearly 85 feet long. Making a mold of that, casting it, and shipping it in 1905 was...
A logistical nightmare.
And he didn't just sell them, he gave them away, right?
He gifted them to heads of state. King Edward VII of the UK asked for the first one for the Natural History Museum in London.
Wow.
Then he sent them to Kaiser Wilhelm II in Berlin, the President of France, the President of Mexico, the Emperor of Austria.
It's like the early 20th century equivalent of a friendship bracelet, but it weighs tons and takes up a ballroom.
Exactly. But the result was that for millions of people across Europe and Latin America, Dippy, as the London cast was affectionately called, was the first dinosaur they ever saw.
Right.
Before T-Rex became famous, Diplodocus was the dinosaur because it was the one standing in the capital cities.
I read a detail in the notes that really drove home just how famous this thing became. It involves World War I.
Oh, the tank, yes. In 1915, the French army was testing a new machine for crossing trenches. It was a prototype tank. Big, boxy, clumsy.
And the soldiers nicknamed it what?
Diplodocus militaris.
That is wild. You know you've made it as a cultural icon when soldiers in the trenches are using your name as slang for giant lumbering beast.
It shows that by 1915, the word Diplodocus was already shorthand for Leviathan.
Speaking of leviathans, let's get into the actual anatomy, because giant is a relative term. The classic Dippy, the Carnegie specimen, is big.
It's big.
But it's not the biggest, is it?
No. And this brings us to a really interesting scientific detective story involving a dinosaur formerly known as Seismosaurus.
The Earthshaker. That is arguably the coolest name in paleontology.
It's up there. In 1991, a partial skeleton was described in New Mexico. The researchers took a look at the vertebrae and did the math. They estimated this animal was 52 meters long.
52 meters. That is over 170 feet.
Which is, frankly, hard to imagine.
It's half a football field.
It would have been the longest animal to ever walk the Earth by a massive margin. It became legendary overnight. But science is a self-correcting process. Years later, other paleontologists took a closer look at the spine.
Yeah.
It turns out there was a mistake in the assembly.
They put the puzzle together wrong.
In a way, they had confused the 12th through 19th vertebrae for the 20th through 27th. They had basically slid the tail further back in the sequence.
So they artificially stretched the animal out?
Exactly. When you correct that alignment, the Earthshaker shrinks. It's now classified as Diplodocus hallorum.
Okay.
It is still the biggest of the diplodocids, coming in around 29 to 33 meters, so over 100 feet. But it's not the mythical 50-meter monster we once thought.
Still, 33 meters. That is over 100 feet of animal. And looking at the proportions, most of that length is just tail.
It's an obsession with length. The tail makes up about 55% of the total body. We are talking about 80 vertebrae in the tail alone. For comparison, earlier sauropods like Shunnosaurus only had about 43.
So Diplodocus took the tail strategy and doubled down on it.
It really did.
So the million-dollar question, why? Nature doesn't usually build 50-foot tails for no reason. I've always heard the supersonic theory.
The whip crack hypothesis. It's the most metal theory we have. The physics actually support it. The tail tapers down to a series of very small, light bones at the tip, the whiplash.
Right.
Computer models suggest that if they flicked it correctly, the tip could travel faster than the speed of sound.
Creating a literal sonic boom.
Yes. A crack like a bullwhip, but loud enough to deafen a predator or signal a mate across miles. It's a compelling image.
But there is a new contender in the theory ring. A study from 2021 proposes something much quieter.
But maybe more sophisticated.
This is the sensor theory, right?
The tactile sensory organ theory. Think about the logistics of being 100 feet long. Your head is way up front. You have zero visibility of your back half.
Sure.
You're maneuvering through forests around other herd members. The theory is that the tail acted like a curb feeler on a car, or like a cat's whiskers.
So they were using it to feel their way backward.
Exactly. It allows them to maintain spatial awareness, knowing where the trees are, where the rest of the herd is, without having to constantly swing that long neck around to check.
That makes so much sense. It's like having a backup camera, but it's a tail.
Right.
Now let's go to the other end, the neck. This seems to be the fight that never ends in paleontology, up or down. Are they giraffes or are they bridges?
The giraffe imagery is very sticky because of, well, Jurassic Park. We all want to see the Brachiosaur or Diplodocus reaching the top of the canopy. But for Diplodocus, modern biomechanics pushes hard against it.
And it comes down to what?
It really comes down to plumbing.
Plumbing.
Blood pressure. If Diplodocus held its head vertically, high above its heart, the pressure required to pump blood to the brain would be
Astronomical.
completely. One study estimated they would need a heart weighing 1.6 tons just to fight gravity.
A 1.6-ton heart. That's a Honda Civic beating inside your chest.
It's physiologically improbable. The skeletal structure, the way the neck vertebrae articulate, suggests a neutral, horizontal posture. Think of a cantilever bridge.
Right. The massive tail sticks out back, the long neck sticks out front, and they balance over the hips. They weren't tree toppers, they were mowing machines. They swept that neck side to side, clearing out ferns and mid-level plants.
Okay, I want to pivot back to the history for a second. We talked about Carnegie and the branding, but Diplodocus was actually discovered a bit earlier, right in the middle of the Bone Wars. And I feel like we can't do a dinosaur episode without mentioning how messy that era was.
It was absolute chaos. The Bone Wars were the rivalry between Othniel Charles Marsh and Edward Drinker Cope in the late 19th century. These two hated each other.
I mean, really hated each other.
They were sabotaging each other's digs, rushing descriptions to print, just trying to name more species than the other guy.
And Diplodocus was caught in the crossfire.
It was. Marsh named the original type species, Diplodocus longus, in 1878, but he based it on just two-tailed vertebrae.
Wait, 2 bones, that's it. That's the entire basis for the species name. And that is a huge problem for modern scientists, because two-tailed vertebrae aren't really distinct enough to prove that a species is unique compared to other similar sauropods.
So, strictly speaking, the original type species, Diplodocus longus, is now considered a
Nomen dubium.
which means doubtful name.
Correct. It means the foundation of the name is shaky. There was actually a petition fairly recently to the International Commission on Zoological Nomenclature.
Oh, really?
Paleontologists wanted to make Dippy, Diplodocus, carnegii, the one with the beautiful, complete skeleton, the new official reference point, just to clean up the taxonomy.
Let me guess. The rules are the rules.
Bureaucracy is undefeated. The petition was rejected.
Of course.
So we are in this weird position where the official original Diplodocus is a couple of nondescript bones that nobody really uses, but everyone just ignores that and uses the Carnegie skeleton as the real reference.
Well, let's look at what that reference skeleton and the newer finds. Tell us about what they actually look like. Because this is where the mental image update really happens. I grew up with the gray elephant skin giant, but the source material says that's wrong.
It is very outdated. The image update started back in 1990. Paleontologists found skin impressions that showed Diplodocus, or at least its close relatives, didn't just have flat skin.
So what did they have?
They had a row of narrow, pointed, keratinous spines running down the back, neck, and tail.
Spines, like an iguana.
Very much like an iguana. Some of these spines were up to 18 centimeters long.
That's over 7 inches.
Yes. So break up that smooth silhouette in your mind. This animal was spiky. It had a punk rock ridge running down its spine.
And the skin itself wasn't just wrinkly gray leather.
No, the fossils from the Mother's Day Quarry, which is a great name for a sideshow, a huge variety of scale shapes. Rectangular scales, ovoid scales, arching rows of square scales.
Globular scales.
Yeah, it wasn't a uniform hide. It was a complex tapestry of textures.
And here is where it gets really interesting. The color. Usually when we talk about dinosaur color, it's a guessing game. Maybe it was green, maybe brown.
Total guesswork.
But you have a study here from 2025 that is hot off the press.
This is brand new science. A team led by Gallagher identified probable melanosomes in the skin of a juvenile Diplodocus.
Explain melanosomes for us.
Melanosomes are the microscopic cellular structures that hold pigment. Finding them is the holy grail because it gives us physical evidence of color patterns.
So what did they find?
The study suggests that, particularly as juveniles, they weren't just drab gray. They likely had diverse color patterning.
Which makes sense.
It tracks with what we see in modern reptiles. Baby Komodo dragons or iguanas often have bright stripes or spots for camouflage or display.
So imagine a 20-foot-long juvenile Diplodocus covered in spines with stripes or spots.
It changes the whole vibe. It makes them feel like real animals living in a complex ecosystem, not just movie monsters.
Which leads us to that ecosystem. The Morrison Formation, 150 million years ago. If I stepped out of a time machine, what am I seeing?
You aren't seeing a tropical jungle. That's another movie trope. The Morrison was semi-arid. Think of a savanna. But instead of grass, because grass hadn't evolved yet, it's dominated by ferns, cycads, and horsetails. There are conifer forests along the rivers, but there are distinct wet and dry seasons. It's a harsh, demanding environment.
And it's crowded.
Incredibly crowded. This was the golden age of giants. You have Diplodocus, Apatosaurus, Brachiosaurus, Stegosaurus, Comorosaurus, all sharing the same space.
And of course, the predators like Allosaurus and Ceratosaurus hunting them.
Right.
The question I always have is, how? How did that many multi-ton animals survive in a semi-arid place without eating every leaf in sight and starving?
That is a magic of niche partitioning. They all order off different parts of the menu.
Right.
And this is where the Diplodocus teeth tell a fascinating story.
Go on.
If you look at their skull, they only have teeth in the front of the mouth, and they look like pegs or pencils.
And they don't chew, right? No molars in the back.
Zero chewing. If you are a Diplodocus, you don't have time to chew. You are a bulk browser. The wear patterns on the teeth suggest a technique called unilateral branch stripping.
Unilateral branch stripping. It sounds like a gardening violation.
It's brutally efficient. They would clamp onto a branch with those peg teeth and pull it through one side of the mouth, raking off all the leaves and stripping the soft bark. Then they'd swallow the whole mass.
So they're basically giant rakes.
Exactly. And because they didn't chew, they didn't need massive jaw muscles. This kept their heads small and light, which allowed them to have that incredibly long neck. It's all connected.
And that's how they avoided competing with the neighbors.
Right. Commersaurus, for example, lived right next door. But it had big spoon-shaped teeth and a strong jaw. It was eating the tough, woody vegetation that Diplodocus couldn't handle.
And Brachiosaurus was reaching the high canopy.
Exactly. Diplodocus was sweeping the ferns and soft mid-level branches. They split the buffet so they wouldn't starve each other out.
Now, we also have new information on their life cycle. The standard assumption with dinosaurs has been live fast, grow huge, die young.
Generally, yes. The idea is that you need to sprint to adult size as fast as possible so the Allosaurus can't eat you.
Right.
And for the classic Diplodocus carnegii, that seems true, they likely reached sexual maturity in just over a decade, which is terrifyingly fast for an animal that size.
But there's a twist in the 2024 study regarding the big one, Diplodocus hallorum.
This is a really fascinating divergence. A study by Woodruff and colleagues looked at the histology, the microscopic structure of the bone tissue of D. hallorum.
And what did they find?
They found that this specific specimen was old, like really old.
How old?
They estimated around 60 years.
Is that unusual?
It's very old for a dinosaur. Most estimates put them in the 30s or 40s. A 60-year-old animal implies a much slower, more prolonged growth rate.
Interesting.
It suggests that D. hallorum didn't just sprint to the finish line. It kept growing and lived a long, sustained biological life.
It adds a layer of complexity. It's not just one rule for all of them.
Exactly. And speaking of complexity, we have to talk about the babies. We know that the juveniles didn't just look like miniature adults.
They had different faces.
Totally different faces. We've found juvenile skulls where the snout isn't as blunt and square as the adult. The teeth weren't restricted just to the front. They extended further back in the jaw.
Which means they were eating different things.
Precisely. The babies were likely generalized browsers, maybe eating insects or more specific plants, while the adults were the specialized fern rakes. It's a brilliant evolutionary strategy.
You don't have to fight your own children for dinner.
That's it.
So, let's try to put this all together. When we strip away the museum lighting and the plastic toys, what are we left with?
We are left with a sophisticated survivor. Diplodocus isn't just a pile of bones. It's a creature with a sensory-aware tail that acted like a navigation system. It's an animal covered in protective spines and complex camouflage patterns.
It's a browser that engineered its own niche in a crowded ecosystem. And it's a reminder that science is never done.
Absolutely.
We've had these bones for 140 years. Carnegie cast them in plaster over a century ago, and yet we learned about their skin color last year. We learned about the aging of D. hallorum 2 years ago.
That is the beauty of paleontology. The fossils don't change. They sit in the drawer. But our technology changes. Our ability to ask questions changes. We can now look at melanosomes and bone histology in ways Marsh and Carnegie couldn't even dream of.
Before we wrap up, I want to leave our listener with one final image to mull over. We've talked about the tail, the neck, the spines, but I want you to look at the hands.
Yeah, the thumb claw.
If you look at the front feet of a Diplodocus, they are arranged in a vertical column, almost like a horseshoe or an elephant's foot. But on the inner toe, there is one single, unusually large claw.
Right.
It's detached from the hand bones, just hanging there.
And then the other toes have nothing, just pads.
It looks bizarre, like a giant hook. And the best part, we have absolutely no idea what it was for.
None. There are theories, of course. Maybe it was for digging up roots. Maybe it was for stripping bark. Some think it was a weapon for defense or used in grooming.
To scratch those itchy spines.
Yeah, but there is no consensus.
No consensus. It's just there. It is a giant, mysterious hook on the hand of the world's most famous dinosaur. A little reminder that even with the celebrity of the Jurassic, there are still pieces of the puzzle missing.
And that is why we keep digging.
Thanks for joining us on this deep dives. We'll catch you on the next one.
Keep exploring.